Now right away, you should notice there's no log anywhere on this page. Now we're not solving logarithmic equations, we're solving exponential equations. Probably got to use logs to do that, but that's how it goes. So you could either look at this and go, I'm going to rewrite that. So the base of a logarithm is 8, and the other two switch places. It'll look like this. Log base 8 of 9 equals x. Or you could take the log of both sides. So watch, I'm going to do this problem two different ways. I could go log of 8 to the x equals log of 9. You have two choices for how to do this problem. Once you do this, you can use that change of base formula that you and I were just talking about this morning. And you could go, that's going to be the log of 9 over the log of 8. And it just goes in your calculator. Log of 9 over log of 8. Log 9, finish parentheses, divided by log of 8. I get 1.057, I guess we'll say. X is approximately 1.057. If I decided to take the log of both sides, look what happens. The x comes down in front. X times the log of x is equal to the log of 9. I said x, but I meant 8. And then to get x by itself, you divide. So you get the log of 9 over the log of 8. And look, that's the exact same thing we have over here. So two different ways to solve that problem. Depending on which one you prefer, you could either take the log of both sides, bring the exponent down, and get the exponent by itself, or just rewrite it and use the change of base formula. Okay, this second one, I can't just rewrite this one because there's not just one exponent. There's a couple of them, so this is a hot mess. I'm going to have to take the log of both sides. So I go the log of 6 to the 1 minus 6x is equal to the log of 5 to the x. Now, when I do that, because it's now a log, the exponents come down, just like this x would come down. So I'm going to put in parentheses 1 minus 6x times the log of 6 is equal to x times the log of 5. Now I can see you getting stuck right there thinking, oh, okay, I have no idea what to do next. Your job is to get the x's together. That can't happen with this being stuck in parentheses, so we're actually going to distribute this log of 6 to both of these. So I get 1 times the log of 6 minus 6x times the log of 6, which looks weird, is equal to x times the log of 5. Okay, now we're getting someplace. I want to get this x together with this x. Since this is minus, I'm just going to add this so that the two x's are together over here. Okay, so I have log of 6 is equal to x times the log of 5 plus 6x times the log of 6. That's a 6 right there. Okay, x's are now on the same side of the equation. What I can do here is the distributive property. I'm going to factor the x out of these two. This is a weird looking problem for sure, so maybe read through it, watch the video a couple of times, make sure you get all the steps here. I'm going to factor this x out of the right side of the equation. X times, I'll be left with the log of 5, and over here if I take the x out, 6 times the log of 6. And now I can just divide this whole hot mess right here and put it underneath this one, and x is by itself. And the rest is in the calculator. So x equals the log of 6 over the log of 5 plus 6 times the log of 6. Okay, go right in the calculator with all of that mess. I'm going to go the log of 6, make sure you finish your parentheses, divided by, I'm going to open parentheses because I got a plus down here, and I will go log of 5, finish the parentheses for the log, plus 6 times the log of 6, finish the parentheses for the log, finish parentheses for the denominator, and I get x equals 0.14496. Okay, that was tough. Yeah, that was definitely difficult, especially with 2 weeks off, basically. This next one requires something called a U substitution. That's in your notes. I remember doing it in your notes. This would be impossible to do as it is, but I'm going to remember that if you raise an exponent to an exponent, you multiply them. Okay, so since I have a 7 to the x, I would like this to look like 7 to the x. So watch how I'm going to write this. 7 to the x squared plus 7 to the x minus 42 is equal to 0. Now I have a 7 to the x and a 7 to the x. Okay, you ready for the u substitution? Here we go. I'm going to let u equal 7 to the x. I'm going to make like a little mark in the middle of my problem here. What that means is I could rewrite this for the moment as u squared plus u minus 42 equals 0. I just took 7x out and I put u in, so u squared and u. Now that I did the u substitution, I can see that I can factor this pretty easily, right? So I'm going to set parentheses, and I'm going to factor this. Put a u there, put a u there. 42 is definitely 7 times 6, and when I combine them, I can turn them into a 1. So it kind of factors pretty quickly. I need different signs, and I want the result to be positive, so the 7 gets the plus and the 6 gets the minus. So u equals -7 and u equals 6. Now I'm going to finish this as a box. I just solved that with a u substitution, but this is still about x's, right? So here's the case. Since u is equal to 7 to the x, -7 is equal to 7 to the x, and 6 is equal to 7 to the x. Whatever you get as an answer, you just put it right there and solve this. All right, that's the trick to the u substitution problem. So solving this would require me to, I'm going to rewrite this, right? I'm going to go log base of 7 of -7 is equal to x. The base of the exponent is the base of the log, and the other two switch places. Well, you can't take the log of a negative, so this doesn't actually give us an answer. This one I get to cross out. This one here, the log base 7 of 6 is equal to x, and I could just put that in my calculator. What is the log base 7 of 6? Well, I could use the change of base formula and go log of 6 divided by log of 7, which we've done a couple of times during this review, and I can get 0.9208, or I don't know if your calculator does, but mine does. If I go to math, I think, and I go all the way down, there's a log, yep, log base right there. So it'll let me put in a base. So log base 7 of 6 is another way to do that, and I get the same answer. All right, next page.